So in this video, we will talk about polar equations. Here, we are going to be given an equation and we want to convert them to polar. So let me start off by an example. The best way to do them is just by doing examples. So let's convert the equation x squared plus y squared equals 9 to polar. Okay, so this one, really what we want to be able to tap into is the equations x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and then tangent of theta equals y over x. So these are the ones that we really want to be able to tap into. So what we're going to do is we're going to go ahead and plug them in so that we can get rid of the x and the y. So x in this case is going to be r cosine theta, so that's what we're going to plug in, r cosine theta, and we're going to square it because there's a square there, plus y is going to be r sine theta, and then we're going to square it, and this is going to be equal to 9. And now we're going to solve for the value of r. Sometimes it will be really easy to do it, sometimes it might be a little difficult. So you're going to get r squared cosine theta plus r squared sine squared of theta. Oh, I forgot the squared. Is equal to 9. Here, notice that I can factor out an r squared, and I can get cosine squared theta plus sine squared theta equals 9. We know by the Pythagorean identity this is equal to 1, so all I'm left with is r squared equals to 9. Take the square root, r is equal to 3. Okay, now remember we could also use r equals -3 as well, but notice that r equals -3 is just going to be a directed distance. R equals 3 is just a really suitable answer as well. So basically, later on when we get to conic sections, you'll kind of figure out that this is actually a circle. So the equation of a circle in terms of polar is just r equals 3, which kind of makes sense because this is basically the radius. The radius is 3, so r equals 3 should represent a circle in polar form. Okay, so now let's try this one. So what would be x equals 2 in polar? So what would that guy be equal to? Well, I know what x is equal to. X is going to be equal to r cosine theta. So this guy, I'm going to plug in r cosine theta is equal to 2. I need to solve for r, so I'm going to divide by the cosine theta. So I'm going to get r is equal to 2, and then what's 1 over cosine? Well, 1 over cosine is just secant theta. So 2 secant theta is actually just a straight line, x equals 2. Okay, so if I were to draw the line 2, this line is represented as 2 secant theta. Okay, all right. Now let's do another one. So let's say we had x squared is equal to 4y. Okay, which actually this is a parabola. So now let's start off by plugging in x and y to try to eliminate them. So this guy's going to be r cosine theta squared equals 4r sine theta. Okay, so squaring this will give me r squared cosine squared theta is equal to 4r sine theta. Okay, now what we're going to do is we're going to move the r's over, so 4r sine theta to the other side. So we're going to get r squared cosine squared theta minus 4r sine theta equals 0. In this case, notice that they both have an r in common, so I'm going to have r and then r cosine squared theta minus 4 sine theta is equal to 0. So then I can break this up into two different forms, r equals 0, and then r cosine squared theta minus 4 sine theta equals 0. Notice that this guy doesn't really give me anything. That's just a pole. And obviously this is not the origin, right? This equation clearly is not in the origin. I mean, it goes through the origin, but that's not what we want. So now this guy, we have to figure this out. So let's try to solve for r. So let's add the 4 sine theta back. So we're going to have r cosine squared theta is equal to 4 sine theta. Then we're finally going to just divide by the cosine squared theta to both sides. So we're left with r is equal to 4 sine theta. Notice that in the bottom, I can write cosine squared theta as cosine theta times cosine theta, because there's 2 of them on the bottom. We can kind of see that r is going to be equal to 4. This guy is just tangent of theta. And then this guy, where there's imaginary 1, is going to be secant of theta. So this is the equation for that particular problem. Okay. All right. So now that we've done Cartesian to polar, now let's do the opposite. Let's do polar to rectangular, or Cartesian. So convert to rectangular. And these can get a little complicated because sometimes you have to do a little bit of tricks. Okay, so let me start off with the first one. So r is equal to 5 secant of theta. All right, so the first thing that I can see is that you want to keep it in mind that you want to have it in this form. So we have to somehow get an r sine theta or r cosine theta, or just have tangent of theta is equal to y over x, or have r squared equals x squared plus y squared, somehow like that. Okay, so I have secant. I think what I want to do is divide by secant theta to both sides to have all the trig with the r's. I can move the secant to the top because 1 over secant is just going to be cosine. And remember, r cosine theta is just x, so x equals 5. Okay, so a little bit more algebra. Okay, now what about this one? So let's say we had r is equal to 2 sine theta. Okay, now in this case, it's going to be a little bit hard because if I move the sine theta, just like how I did with the secant, I'm going to get cosecant, and that's quite not what I want, r cosecant of theta. So, but I wish that there was an r next to the sine, because then I can immediately just put a y in there. So that's what I'm going to do. I'm going to multiply both sides by r. So on the first side, r times r is going to give me r squared, and the other one's going to be 2r sine theta. So now I know what r squared is. R squared is just x squared plus y squared. And then I have a 2, and then this guy's just a y. Okay, for right now, just leave it as is. Later on, we're going to complete the square and figure out what exactly this is. But for right now, just leave it as is. Okay, we don't need to solve for y, because actually this is not a function. All right, and now let's do this last one. So let's say we had r is equal to 3 over 1 minus 2 cosine theta. Okay, so I think the obvious thing would just be to multiply both sides by the denominator. So move that over. So you're going to have r 1 minus 2 cosine theta is equal to 3. So let's distribute the r now. So you have r minus 2r cosine theta is equal to 3. Now what is r equal to? Well, if I square root this guy, r is just equal to the square root of x squared plus y squared. Okay, so that means this guy is just a square root of x squared plus y squared. This guy, r cosine theta, that's just going to be x, because r cosine theta is just equal to the x. And this is equal to 3. I can add the 2x over if I wanted to. So I'm going to have the square root of x squared plus y squared is equal to 3 plus 2x. And then square both sides, I end up getting 3 plus 2x whole quantity squared. At this point, you can just leave it as is to get rid of the square roots. Again, we're going to leave it like that for now. So these problems, you can see that if I were to kind of think about graphing it, some of the graphs are going to be really easy. So for example, graphing x equals 5 is very easy. Graphing r equals 5 secant theta might be a little bit like, what is that? Graphing this guy might be a little bit weird, and graphing this guy also might be a little bit weird. But we know that this will give me some sort of, I don't know, either a circle or an ellipse or something, right? So the thing that I want to be able to do in the next video will be, how do I graph things that are in polar form? Because sometimes switching it to Cartesian might not be really easy, and also being able to graph this might involve a little bit of algebra. So how can I use these polar equations that I have here and graph them right off the bat without having to convert? And that's exactly how we're going to end this chapter in the next, or this section in the next video.